Welcome back to Electron Devices and Circuits lecture video series. In this video, we are going to discuss about the topic laser diode. At the end of the video, you will be able to understand what is laser diode, different types of laser diodes available, construction and working of laser diode and applications of laser diode. Let's see the topic one by one. The first one is laser diode. So the word laser stands for light amplification by stimulated emission of radiation. You might have studied in physics itself. So the light is getting amplified by this process of stimulated emission. So the laser diode working under the principle of stimulated emission. The definition of laser diode is, it is a semiconductor device that generates coherent light of high intensity is known as laser diode. So what do you mean by coherent light? In the sense, the light emitted from the diode which is having of same frequency and phase is called as an coherent beam. So a semiconductor device which is having the capability to emit such a coherent beam of light of high intensity is called as an laser diodes. So what are all the different diodes we have discussed so far? PN junction diode, Zener diode, and then light emitting diode, and the next one is a laser diode. So light emitting diode just emits the light signals by spontaneous emission method, whereas here this laser diode emits coherent beam of light by stimulated emission. So keep that in mind, stimulated emission. And this is how the laser diode will looks like when you purchase from the shop. So this is the laser diode. And first one, coming on to the construction. So the construction details of laser diode is, so here this laser diode normally comprises of three layers. So one is the middle layer which is represented by orange color. It is an intrinsic semiconductor layer. Intrinsic in the sense, the layer which is made of pure semiconductor materials without any dopant or doping impurities. That is called as an intrinsic layer. In this layer only the laser beam gets emitted from the diode. So see here, this is the emitted laser radiation, and this is the residual light is going in the another direction. And another two layers, one layer above the top, above the intrinsic layer is a P layer, and another layer below the intrinsic layer is the N layer. And how this P layer and N layer can be formed means, these P and N layers can be formed by the combinations of gallium arsenide semiconductor along with either aluminium or silicon or selenium. See here, aluminium, silicon or selenium to form the P and N layers. So here aluminium is used along with gallium arsenide semiconductor to form a P region and N region. The contact terminals is taken from P region, that is acting as an anode, and another contact taken from N region acting as a cathode. Both above the P region and below the N region, that means surrounding the entire cabinet there is an mirror polished reflecting surface. This is very important, keep it in mind. Around the entire assembly of laser diode there is an polished mirror surface in order to reflect the photons that is hitting the surface. So keep it in mind. So this is also polished partially reflecting surface. This is a completely polished surface and this is partially reflecting surface. So this is the way we need to construct the laser diode. We will see the working of laser diode. As I already informed you, the laser diode works under the principle of stimulated emission. First we will see what is stimulated emission. So normally there are two types of emissions available. One is spontaneous emission and another one is stimulated emission. Before understanding these two, you have to first know about what is absorption. So here listen to this picture. Here you are having, assume any atom. Normally atom is having two state, E1 and E2. E1 state is the ground state and E2 state is the excited state. This is the ground state represented by G and this is the excited state represented by E. So initially some atoms is said to be in ground state and some atoms will be in the excited state. So the atoms in the ground state cannot have the sufficient energy to go to the excited state. So what we have to do means we have to feed some external electromagnetic waves of some frequency to the atoms in the ground state, so that these atoms gains an energy equivalent to the atoms in the excited state. Now the energy difference becomes equal. Now these atoms have the sufficient energy to jump to the excited state E2, and this process we call it as an absorption. That means this atoms absorb some external electromagnetic waves, gains sufficient energy to jump into the excited state E2, and this process we call it as an absorption. This is the basic preliminary process. So next one is, what is spontaneous emission? In the sense, once if the atom reaches the excited state, the atoms retains in the excited state until its lifetime gets over. Once if its lifetime has gone, this atom spontaneously comes to the ground state. This atoms automatically jumps to ground state from excited state. Once it is jumping, it emits an photons. This photons is having an energy equivalent to the energy what it has observed when it is in the ground state. So we will get one photons. That photon is nothing but the light waves. Because of that only we are getting light signals at the output in LED. So this principle is used in the LED. In LED, light is emitting by the process of spontaneous emission, right? And the next one is stimulated emission. Stimulated in the sense we are giving some triggering input to do some abnormalities. So what is it means? Once if the lifetime gets over, the atom automatically jumps from E2 to E1. We are not at all waiting till that period. So what we are doing actually means, we are feeding some external electromagnetic waves equivalent to what it has observed in energy state E1. Now we are feeding some external energy. So once if the atom gains an enormous amount of external energy and it starts to come down from E2 level to E1 level, and it emits the photons, two photons, which is having an energy equivalent to the energy what it has observed in the state E1 and what it has observed in the state E2. Right, so we are having an incident, this is an incident photon of energy and this is the coherent emitted photons. Normally two photons is emitting. So this photon, since all those two photons is having same frequency of electromagnetic waves at same phase also, we call this beam as a coherent beam, having same phase and frequency, coherent beam. Since two photons are emitting, we are getting some we are getting a monochromatic beam, we will say. So once if these electrons are emitted, these photons, two photons are emitting, no, this process we call it as an stimulated emission. So keep that in mind. By stimulated emission, some light signals is emitting from the diode, that is called as an laser diode, and this beam is called as an highly coherent monochromatic beam. Monochromatic beam means a beam with a unique wavelength. Coherent means the beam or light signals having same frequency and phase is called coherent. So such a wave is such a thing is the property of the wave emitted from stimulated emission. So right now you keep it in mind, spontaneous emission is the principle used in LED and stimulated emission is the principle used in laser diode. Okay, so right now two photons are emitted from two photons are emitting while the atom is moving from E2 to E1. So now we'll go back to this construction. So once if the two photons are emitting, so now what happens means this photons goes and hit the polished mirror reflecting surface. Right, so while it is hitting, it bounces back and forth between the mirrored surface itself, and as a result, while it is bouncing, it hits the another atoms present inside the fabrication, present inside this device, and as a result some more photons also gets emitted. So this process is cumulative and it goes on as long as how long it will, as long as its lifetime gets over, and or if once if threshold is reached. So some threshold, in the sense some specific limit will be there. So these photons will be inside the material only for some threshold value. Once if it reaches the threshold value, these photons will emerge from the beam, or it gets emitted from the this laser diode through the intrinsic layer. So see here, this is the beam of light beam that is coming out from the laser diode through this intrinsic layer. This orange color layer is an intrinsic layer, pure layer, I told you. Through it is having a partially reflecting surface. So because of this, once if the threshold value is reached, these electrons will, these photons will emerge from the polished reflecting surface, and we are getting a laser beam here. So this is the principle. Right, so this is the principle, and this laser beam is nothing but the light signals we are observing from the laser diodes. So by stimulated emission only this process is executing. See, and the next one is different types of laser diodes. There are two types of laser diodes, namely surface emitting laser diode and edge emitting laser diode. These two types can be differentiated only based on only one thing, whether the emitted light from the intrinsic layer is parallel or perpendicular to the p-n junction plane. See here, this is p-n junction plane. If the emitted light is in the direction parallel, so see here, this emitted light beam is parallel to the p-n junction plane. So this we call it as an edge emitting laser diode. Edge emitting laser diode. Suppose if the emitted light signal is perpendicular to the p-n junction plane. For example, instead of emitting in this direction, if the beam gets emitted in this direction is perpendicular to the p-n junction. p-n junction plane is in this direction. If it is like this, it is called surface emitting laser diode. So normally we are using the edge emitting laser diode. And the next one is characteristics of laser diodes. So this is the characteristics, you know, x-axis we are taking the current, and y-axis is the optical power of light signals emitted from the intrinsic layer. So as soon as the current is applied, we are increasing the current from a small value to a large value. Once if a specific threshold value is reached, until it is reaching the threshold value, the power, that is light emitted from the laser diode is the power is not that much increasing. See here, the power is very minimum. See here, the power is not at all increasing until it is reaching the threshold here. Once if it reaches the threshold, it is following the stimulated emission, external energy is feeding, and at the same time, even for a small increase in the current, the light output from the laser diode is very high. So this is an non-linear characteristics. So initial period there is no power output. After some threshold value, the power output from the laser diode is getting on increasing. This is a non-linear characteristics. So here up to here, this is spontaneous emission. While spontaneous emission is happening, we will get only one photons. Whereas in case of stimulated emission, to get into the stimulated emission, we have to increase the magnitude of current flowing through the laser diode. Once if you are doing like this, so this comes under stimulated emission. As a result, more and more photons are coming out by bouncing back process, and as a result, once if a threshold value, a large coherent monochromatic beam is coming out from the intrinsic layer, which is called as an laser beam. So this is the characteristics. And the next one is applications of laser diode. These are all the applications, you know. This is self-understood. CD and DVD players, we are having laser barcode scanners. While scanning the barcode, some laser red light will be projecting. This is nothing but laser light. Cable and high definition transmission, medical applications, intruders detection. Intruders is nothing but unauthorized persons entering into some restricted area. For detecting those persons, we are using a laser diode, laser light. Industry applications for precision cutting, accurate cutting of metals, heat treating, welding and all, we are using lasers. And fiber optic range finders is nothing but finding the distance. And printing, we are also having laser printing. It gives a perfection and accuracy will be very high. Integrated circuits also we are using laser technology for having high precision and accuracy. So these are all the applications of laser diodes. Hope at this end of the video you will get a clear idea about the laser diode construction, working characteristics and application. So hope this video will be useful for you. Thanks for watching.